Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too. And especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, friends. Welcome to Wednesday night math night. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons. And I just love what I get to do here. I love sitting here on Wednesdays, going over math problems with you, helping you feel more confident and competent in the math skills that you're doing to prep for that teacher exam. These tests are not easy, and we recognize that, which is why we're here every Wednesday for free, helping you understand what you're doing wrong and just get more confident in those math skills, because that's half the battle, y'all. If you have questions that you want me to go over, please let me know in the comment box or find me on social media, because I always have a next week section. And that is kind of what I use to build up the upcoming sessions. So I already have some patterning questions sent directly to me. Some of the questions tonight are questions that people have specifically requested. And so that helps you understand what you're doing a little bit better. So if you come across a question where you're like, man, I really don't understand this, or I do, but I just want to hear it presented a different way, let me know in the comment box tonight or on social media, and I will be happy to include those in the upcoming weeks. Hello, Leah. Hello, Hope. Two of my favorite people that come to Wednesday night math nights. Y'all are here every week, and I just love seeing familiar faces. Leah, I will include those problems in the upcoming, next week. I just couldn't access them until you resent them to me. It has been a long week. I don't know about you, but this has been a long week, and it's only Wednesday. So in the comment box, let me know where you're from, what test are you prepping for, and has it been a long week for you, or is it just me? And if it's just me, that's okay. But it's been a long week. I asked my boss left and went off campus today, and he was like, hey, can I bring you anything? And I was like, actually, a Diet Coke would be great. And if you know me, you know I only drink like this much. Like if I'm getting a Diet Coke, I'm the person who drinks like the mini cans, and that is enough caffeine for me. And this guy brought me like the 48-ounce like jug of Diet Coke from Chicken Salad Chick today. And I was like, thank you so much. But Lord knows if I drank all of this Diet Coke, I'd be on another planet. Like I can't, I'd be the Energizer Bunny times 300. So it was much appreciated. But I did not drink that entire thing. Nobody at work would want me to drink that entire thing. But yeah, where are you from? What test are you prepping for? And has it been a long week for you, or is it just me? We are going to do some problems today. A lot of the problems I have are a little bit more middle school and high school driven than elementary. However, my elementary people, I didn't forget about you. I always have problems for everybody, so don't run away from me. So don't worry about that. I always have stuff for everybody. And even if it's a middle school and high school problem, I always find something to relate it back to my elementary people and vice versa. So even if it's a problem where you're like, I don't need to pay attention to that, you probably do, because I will relate it back in some way. It's been a long year already and it's only September. Yes, Leah, I feel that. You had a 20-ounce cherry Pepsi. Ooh, those cherry Cokes, those cherry Pepsis, those are on another level. I do love a good cherry Pepsi or a cherry Coke. Y'all are making me feel so much better. I thought I was the only one where this week was like the world's longest week. Like I feel like I've lived multiple lives this week. Hey, Anita, it is so good to see you. I had the opportunity to meet Anita this weekend. So it is great to see you. Hi, Susanna. Y'all, I am so happy there's so many familiar faces here tonight. This is so exciting. All right, you can tell it doesn't take much to excite me. I wish we were all in my living room right now doing math. Like if we could make a Learning Liaisons math night like meetup, how fun would that be? That would be so fun. Like let's all meet in Georgia, in Atlanta for like dinner one night. How does that sound to y'all? Let's do it. Let's make it happen. All right, let's actually do a math problem, because that's really why you're here. You're not here to hang out with me. You're here to do math problems. So let's go ahead and do problem number 1. Hope, why has it been an exciting week? Tell me about it. You said it's been a long and exciting week. Tell me about why it's been a long and exciting week. I would love to hear about that, like an exciting week. You know, I think I'm going to ask if we could literally do like a meetup, maybe like in the spring, like everybody meet in Orlando or everybody meet somewhere and just, we can all go out to dinner. It'd be like book club, but math club. That's what we should tag it. Book club, but math club. Hey, Lizette, it is good to see you. New faces. I love it. Boca Raton. I need to pass the GK math test. Girl, you've got it. The problems we are doing tonight are going to be absolutely perfection for you. So I am confident you are going to do it. All right, let's read problem number 1 together. A linear equation y equals mx plus b describes the relationship between y and x. If the line passes through the point 2, 5 and has a slope of m equals 3, which of the following equations represents this line? Which of the following equations represents this line? All right. So linear equations are GK and above. So like my 6th grade and above, middle school, high school. But elementary people, you need to understand points and patterns and slope in a sense of that it's a pattern. So when we look at this, the easiest way to do this problem is to understand the equation of a line. The equation of a line is y equals mx plus b. So they gave that to us in this problem. However, they're not always going to give that to us. Leah, I'm going to encourage you to just take it one step further. It is not A. Okay? So y equals mx plus b describes the relationship between y and x. Y equals mx plus b, where m is my slope and b is my y-intercept. And Leah, you are going to kick yourself when you realize what you did wrong. Your y-intercept is where the graph crosses the y-axis. So not a big deal. We got this. I'm going to draw my graph. And I'm going to plot the point 2, 5. So I'm going to, and remember, this is like me drawing this. So it's not going to be 100,000% accurate, but we're going to do our best. 3, 4, 1, 2, 3, 4, 5. Over 2, up 5. Over 2, up 5. My point is right there. That is not the y-intercept. And that's where you went wrong. And it's not a big deal. That is not the y-intercept. It's just a random point on this line. And it has a slope of 3. So I'm going to rise 3 and run 1. So rise 3, 1, 2, 3, run 1. And then I can go down and over left to do the same thing. Rise 3, 1, 2, 3, run 1. And there's my line. Now, did that give me a y-intercept that I can like see? Not really. And like I said, that when you graph it like this on your own, you're risking not connecting the dots exactly the way they should be. So the best way to solve this problem is to use a different format. So while this is slope-intercept form, I don't have my intercept. I have a random point. I can use point slope form. Y minus y1 equals m times x minus x1. And I can plug in my point and my slope into point slope form. Y'all, mathematicians are not creative when it comes to that kind of stuff. So I can plug the point I was given and the slope I was given into point slope form and then just solve for y equals mx plus b. So I am going to take this form, copy it, paste it right down here, and I'm going to plug in what I know. I know y minus y1 equals m times x minus x1. Now I can just get y by itself. So I'm going to distribute this through. Elementary people, you need to know what the distributive property is. The distributive property says I can take that 3 and multiply it all the way through. I can distribute it. So y minus 5 equals 3x minus 6. And you say, hold up, Amy, where did you get that 6 from? Because I have to make sure I do 3 times the x and 3 times the negative 2, which equals negative 6. Add 5 to both sides. Y equals 3x minus 1, which is D. So my y-intercept is actually negative 1. Excuse me. Woo! So my y-intercept is actually negative 1. Now, when we look at the graph that I drew, now you see why I told you don't rely on this graph. Because I didn't necessarily count exactly correct. I counted correct, but my graph is definitely not to scale. That's what I should say. My graph is not necessarily drawn to scale. And so I tried my best when I connected those lines. It should have connected down here somewhere, but that didn't really connect. And it's because I'm not graphing on graph paper. So that's why when we're doing something like this, if you don't have graph paper in front of you, and some tests give you like a sheet of graph paper and some don't, you definitely want to think about doing it the algebraic way. All right, let's go ahead and move on to problem number 2. If you have any questions about these problems, let me know. If you want to see another problem similar to it in the upcoming weeks, just say, hey, can we do another one like number 1? And that will help us as we move forward. If you're just now joining us, I always have a next week section. So if there's a specific section that you're struggling with, Lizette, I know you're trying to pass the GK. If there's something you're struggling with, or if as you're studying, there's a problem that you're like, oh, I wish she would go over this, drop it in the comment box and let me know, or send it to me on social media and I'm happy to include it. All right, moving on. Problem number 2. The graph y equals f of x is shown and passes through the points indicated. The function f is differentiable for all values of x except x equals -4. Based on the graph, which of the following is true? Based on the graph, which of the following is true? The derivative of f of -4 equals 0. The derivative of f of 1 equals 0. For x is greater than 0 and x is less than 4, the derivative of x is greater than 0. For x is greater than -4 through x is less than 0, the second derivative of x is less than 0. Y'all, that was a whole lot of math words. Now, I will say, this is one of the very, 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 very few problems where there's not a whole lot of application for my elementary people, other than maybe understanding how to graph a point. So elementary people, you can take a breather, go to the bathroom, get a drink of water, come right back, because the next problem is going to be for you. But this problem is really, really for my high school people, because we're talking about derivatives. So all of my GK middle high school people, this is considered a piecewise function. While that's not important for this problem, I need you to understand what a piecewise function is. And it's just when we take different pieces, puzzle pieces of other functions, and we smush them together. So we have this piece, which is a straight line, or what appears to be a straight line. And then we have this piece, which is a parabola. And then we have this piece, which is another straight line. We know that that's not part of the parabola because the slope is consistent. Now, with that said, what do we know? We are looking for the derivative or second derivative of this function, because all of these answer choices are either the first or the second derivative. With that said, let's take a look at what that means. Remember, the first derivative is represented by the slope of the tangent line. The second derivative is represented by the concavity of the function. So the first derivative is the slope of the tangent line. The second derivative is the concavity of that function. Concavity meaning, like, is it concave up or is it concave down? Concave up, concave down. And it doesn't have to be a parabola. It could be a weird shape too. But what is that concavity look like? So this would be a positive second derivative. This would be a negative second derivative. And so if we're looking at this, we can see that the derivative at -4, well, it just told us that it's not differentiable at x equals -4. So while it appears that the derivative or the slope of that line tangent at -4 would be 0, the problem literally told us it's not differentiable at f equals negative, or at x equals -4. So that is going to be an automatic given that that's not the correct answer. The derivative at f of -1 at x equals 1. Well, x equals 1 right here. The function f of x equals 0 at x equals 1. The function itself, the y value. However, the first derivative of that is going to be the slope of the line tangent right here, which is just 1. The slope of this line, this whole line right here, is rise 1, run, rise 1, run 1, rise 1, run 1, rise 1, run 1. So the slope of this line tangent to the point x equals 1 is just going to be 1. It's not going to equal 0. So that's not correct either. Now we're looking at ranges. So for x equals 0, through x, or x is greater than 0, x is less than 4. That range goes from here to here. So it's this whole section of the graph, which is that straight line again. So for that section, the first derivative is greater than 0. Well, that's absolutely true. The first derivative is greater than 0 because the slope of the line tangent at any of these points is going to be positive. So that is true. Let's take a look at the next one. For -4 to 0, so from here to here, so this section of the graph, the second derivative is less than 0. Well, remember, second derivative, we're really looking at the concavity of that graph, and the concavity of this graph is up, which means that the second derivative is going to be greater than 0 because it's going to be positive. If the graph was upside down, if it was concave down, then the second derivative would be less than 0. But because f of x is concave up for that range, we are looking at a positive second derivative, which is why D is not the correct answer. So while this looks really complex, it really isn't when you think about it. Questions about this one? All right, let's keep going. All right, so my elementary people, I told you that the next one was for you. This one's not for you, but there's a whole lot of vocabulary in here that is for you. So I'm going to read the problem, and then we'll talk about the vocabulary, and then we'll talk about the problem itself. P is the center of the circle shown, whose diameter is AB. If PM is parallel to AN and the measure of angle MPB is 35 degrees, then the measure of angle MPN is 25 degrees, 35 degrees, 45 degrees, or 55 degrees. All right, so let's list circle vocabulary first for my elementary people. We have diameter, center, radius, and those are really the big ones that we need to know. Radius is half the distance from the center to the outside. Diameter is the distance from one side to another. But the key to that is it has to go through the center. And center of the circle is pretty much common sense. So with that said, they also told us that PM is parallel to AN. So the orange lines are parallel. And the measure of MPB is 35 degrees, which they labeled right there. So they want to know, what is the measure of angle MPN? What is this? Whoops. What is this one right here? So we can't just assume anything based on the information they've given us. But what we can do is use the information they gave us to kind of broaden what we have here. So I have two parallel lines that are being cut by a transversal here and here, right? And sometimes it's easier to see it visually like that. And so what I have here is I have an angle right here that's 35. And if that angle is 35, then that means that this one is 35 too, because those are that's not how you spell corresponding. Corresponding angles. So if MPB is 35, then NAP is 35 as well. And keep in mind, this is only because we have parallel lines. Now, what other information do we know? Elementary people, this is where you come back in. I know that this is the same measure as this. How do I know that? Because they both go from the center to the outside, which means they are both what? They're both radius. Well, if those are both the same, if I have a triangle that looks like this, and this side is the same as this side, then this is an isosceles triangle, which means that this angle is going to be the same as this angle because it's opposite the same sides. So if this is 35, then that means this is also going to be 35. And now I have 2 of my 3 angles of my triangle. How many degrees are in a triangle? How many degrees are in a triangle? 180. So if I know that there's 180 degrees in a triangle, I can do 35 plus 35 plus question mark to figure out what this angle is. Are you seeing how I'm kind of building and chunking until I get to where I'm going? Let's figure out what that is. So I'm going to use my calculator. $35 plus 35 equals 70. So 180 equals 70 plus box. 180 minus 70 is 110. So the pink angle equals 110. Now let's zoom in on this a little bit because we got a lot going on here. Yes, Leah, triangles equal 180 degrees. So if this guy is 180, if that guy's 110, this one's 35, I can figure out my missing angle. Because a straight line also equals 180 degrees. So if a straight line equals 180 degrees, I can do 180 minus 110, which is what that pink angle is, minus 35, which is what MPB is, and then we're left with the blue, which is 35. Y'all, we just pieced that together. And I'm telling you right now, that is often how a geometry problem is going to go. It's going to be you taking little pieces of information that you know and just building on it. Don't try to figure out what MPN is in one step. And don't try to figure out what MPN is in your head, and be like, okay, I'm going to do this, then this, then this. Sometimes you just have to start labeling stuff and the doors will start to open up as to how to solve that problem. Does that make sense? Questions, comments, concerns? All right, let's go ahead and move on to the next problem. Jamie was given 9 toothpicks. If each toothpick represents only one side of a shape, what 2 shapes could Jamie make with the toothpicks? The shapes will share one side, creating a composite figure. And she must use all the toothpicks. She must use all the toothpicks. All right, let's go ahead and do this problem. And then Leah, I will actually, you know what, Leah, I'll go back to that problem and answer your question. So you said, did we have to do all that work if angles that are next door to each other equal the same degrees? Okay, I am going to take this, duplicate it, okay, so you're saying angles that are next to each other, and I'm glad you asked this question because someone else had it. Angles that are next to each other have the same degrees. Angles that are next to each other do not necessarily have the same degrees. In this problem, these just happened to both be 35. However, this could have easily been something like this, where this one was 35 and this one was bigger or smaller. I think what you're thinking of are vertical angles. And so vertical angles are the same. And that would be something like this, where this angle and this angle are the same because they're exactly opposite of one another. It creates an X. But that's only the case if you're creating that X shape. So this and this are the same, and this are the same. It's not because they're next to each other. Does that make sense? So like if this line was extended, then this angle would be the same as this angle. And if this line was extended, then you could do the same thing. Like this one would be the same as this one, and this one would be the same as the other one, but it's not next to each other. I'm glad you asked that question for clarification, though. All right, let's go ahead and reconnect the iPad, and then we'll keep going. All right. It looks like the iPad decided to disconnect. So let's just reconnect it. While I'm doing this, let me know in the comment box what you want to see me go over in the upcoming weeks. What concepts are you struggling with the most? Let me know in the comment box, and I will absolutely use that information to create the upcoming weeks sessions. All right, here we go. Here we go. Here we go. Here we go. Go, go. Here we go. Here we go. Here we go. Go, go. All right. Let's go back to our toothpick problem. So we already read the problem. Piecewise function similar to problem 2 and anything trig related. Okay. Trig and piecewise similar to number 2. You got it. Back to our toothpick problem again. Third time's the charm. All righty. So this is definitely for my elementary people. This one is definitely for my elementary people. Everybody needs to know it, but it's definitely written for those elementary people. So Jamie was given 9 toothpicks. We would assume if we're building shapes with 9 toothpicks that it would look something like this, where we would go, I'm going to try to find my brown color because toothpicks are usually, okay, brown's not working, so we'll use orange. So if I was to create a triangle with toothpicks, it might look like that, and then a square with toothpicks, it would look, or a rectangle with toothpicks, it would look like that. And so 3 plus 4 equals 7. So that would be 7 toothpicks. So in order to have 9 toothpicks, we would need like 1 plus 8 or 2 plus 7 or 3 plus 6 or 4 plus 5 or 5 plus 4 and so on, right? And so a triangle and a hexagon would be 3 sides plus 6 sides. A triangle has 3 sides, a hexagon has 6 sides. And I'm going to go down and do that. A hexagon has 6, a rectangle has 4. A pentagon has 5, a rectangle has 4. A rectangle has 4 and a trapezoid has 4. Okay, so we have our distribution here. And then it says, okay, we need 9 toothpicks. Number one mistake people are going to make, they are going to say A and C. And they're going to go, oh no, I have 2 right answers. Well, I'll just pick A because it's a triangle and hexagon and that sounds correct. Wrong. Let me show you why. It says a critical piece of information. The shapes will share one side, creating a composite figure. A composite figure is 2 shapes that are together. So this right here could be considered a composite figure because it's a rectangle and a triangle pushed together. Do you see that? Do you see that? There it is. And so if we're thinking about a composite figure, then if I put my triangle and my hexagon, okay, let me erase that and redraw it so it's a little cleaner. If I put my triangle and then my hexagon together, then how many toothpicks did I actually use? 1, 2, 3, 4, 5, 6, 7, 8. I only used 8 toothpicks, not 9, because they're sharing that side. So then if I do a hexagon and a rectangle, a hexagon, 1, 2, 3, 4, 5, 6, and a rectangle, how many toothpicks did I use? 1, 2, 3, 4, 5, 6, 7, 8, 9. So B is actually the correct answer because if I have composite figures, if I'm having the shapes share one side, then I'm actually using 1 less toothpick than my equation would say. Does that make sense? Okay, let's do another problem. Geometry for Praxis 7813. 7813 geometry. All righty. Let's go ahead and move on to our next problem. This is a fun one. If 4/5 x minus 6 equals 24, then what does 1/2 x minus 9 equal? If 4/5 x minus 6 equals 24, then what does 1/2 x minus 9 equal? All righty. So what I need to do, my first step is going to be find x. Because if I find x, then I can plug x in over here into my expression and solve. I can plug x in over here and solve. So let's go ahead and solve for x in our equation and then plug that x value into the expression. So 4/5 x minus 6 equals 24. How do I solve this? This is for everybody. How do I solve this? Add 6 to both sides. So 4/5 x equals 24 plus 6 equals 30. And how do I go ahead and solve that? How am I going to solve that? Well, x is being multiplied by 4/5. So I could divide both sides by 4/5. However, then I have to do a whole nother step because I can't really divide fractions. I have to end up doing keep, change, flip. So keep, change, flip, when really what I could do is just multiply both sides by the reciprocal. Because what happens is I end up with 20 over 20, which equals 1. So that all completely cancels out. So I'm left with x anyways. And then I don't have to do the whole keep, change, flip thing. So 30 times 5 is 150 divided by 4. And 150 divided by 4 equals 37.5. If you have a 4-function calculator in front of you, this becomes super easy. Valeria, you are absolutely right. Now I can go ahead and plug that into my expression. 1/2 times 37.5 minus 9. Remember, order of operations says that I'm going to do that piece first. So 37.5 divided by 2 is 18.75 minus 9. And when I plug that into my calculator, I end up with 9.75, which is B. Questions? All righty. We are going to end just a couple minutes early because, fun fact, my school is on a huge retreat right now, and I am actually managing the entire attendance platform from this side of the retreat. So from home, from my computer. And so I have to get ready to, they're getting ready to like do something with it. And so I have to manage that piece of it. And so the joys of being an assistant principal, I absolutely love it. So we're going to end just a couple minutes early tonight, but with that said, I am going to include these requests that you have provided me. And so I'm going to turn it over to Dr. A, and I will see you guys next week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today. And hopefully we'll see you next week too. Talk to you soon.